Hey guys, my name is Zheming.
Hello, my name is Guo.
Today our topic is Introduction of Simula. The history of Simula. The first object-oriented program language was developed in 1960s at the Norwegian Computing Center in Oslo by two Norwegian computer scientists, Old and Kristen. Kristen, he was seeking for a better way to describe the heterogeneity and the operation of a system. To go further with his ideas on a formal computer language for describing a system, thus he contacts Ojo Handel, also a master in mathematics and one of the Norway's foremost computer scientists, who joined him in January 1962. By May 1962, the main concepts of the simulation language were set. The first formal definition of Simula 67 appeared in May 1967. In June 1967, a conference was held to standardize the language and initiate a number of implementations. They are proposed to unify the type and the class concept. This led to serious discussions and proposal was rejected by the board. Simula 67 was formally standardized on the first meeting of the Simula Standards Groups in February 1968. So Simula 1 and Simula 67. Simula was invented for the purpose of creating computer simulations. And that is what led to the development of object orientation. Discrete things that needed to be simulated with a system became the first objects. And Simula is the name of two closely related computer programming languages. The first version of the language, Simula 1, was developed as an extension of Algo, with special tools and features added to add the simulation of real-world events and systems. The second version of the language, Simula 67, was developed a few years later and introduced a number of concepts which would later form the basis of object-oriented programming. And this version of the language was hugely influential in the development of several other languages, as well as to the whole discipline of computer programming and language design in general. Influence and chance of Simula. Work on Simula led almost directly to the Smalltalk language, which went further defining object-oriented concepts. C++, perhaps the most important language for system programming, was inspired by Simula. So are people still using Simula? Not that much. It's impossible to say that no one is using it, but suppose an interest for the language is certainly very low at this point. So some people are still using Simula in Norway, where this language was created. There haven't been any new books on Simula in a long time, and most of the web resources were several years old as of this writing. Most of the interest in Simula has been among academics and educators. This is the graph of the users in Simula. There were less and less users in similar languages. Okay.
A main feature of Simula is built-in simulation capability. It is easy to build for specific program domain and will therefore be used as the basic for specific application languages. Simula 67 includes the universal algorithm language ALGO 60 as a subset, except for some very minor modifications. The reason for choosing ALGO 60 was that its basic structure lent itself for extension. Since ALGO 60 has already a user basis, it would be impractical for users to base Simula on another new algorithmic language. As we introduced at the beginning, Simula is the first object-oriented language. So let's look at our first example on simulating students' graduation requirements. Undergraduate student and graduate student are both subclass of students, but they have different credits requirement for graduation. In here, we have a virtual method, dynamic graduation. It can be overridden in subclasses. So when we print, the result will show the total credit requirements for a specific student, like we did in Java. So here's the demo. I execute it, and then it prints out the total credit for the first student is 120s, and the second one is 60 for the graduate student. Okay, so next we are going to look at a slightly complicated simulation on simulating a drive-through system. It has three status: order, checkout, and take meal. In each window, the car needs to wait until the previous car moves on. As you have noticed in the code, it's using wait method and Boolean to simulate the stop and wait procedure. But in real-world situation, sometimes checkout and take meal need more time. We can illustrate this situation in our code as well. Here are just some indications and car information we set up for testing. So let's look at the result. The first car is easy. It just ordered, paid, and then take the meal right away because he's the first customer. But the second car here has a little trouble. It has ordered and paid already, but he is not getting the food. Maybe what he ordered was sold out and he has to wait for another 2 minutes for the kitchen to cook. So while he is waiting, we can see that the next car, plate number starting 224, is ordering and also paying behind. But 224 cannot pass and take his meal even if he's only buying a cup of water because the previous car is blocking the way. So it's sorry that he has to wait. Our code perfectly shows this situation. And the following results are about the same idea. So after the food is ready, the previous car take the meal and followed by the 224 car take the meal as well. So another code example. So here are the code example for the second one. And this is our reference.
Okay. In conclusion, the majority of computer programming languages today are object-oriented, and object-oriented programming is the primary coding paradigm used by software developers. Conceptually, Simula influenced all of these languages.
However, theory and practice in the object-oriented field have developed a great deal since 1967, and Simula does not conform to all of these characteristics usually considered indispensable for a fully object-oriented language. So this is our presentation. Thank you for watching.
Thank you.